morning and welcome to the final 2 days of the Spaces Virtual Conference on the theme of Net Zero Carbon Climate Emergency 2021. My name is Steve Rufus and I'm the Construction Design and Delivery Manager for Dorset Council and Spaces Vice President, and I'll be your chair for the webinar. Before commencing with the introduction of our speakers, I'd like to thank our 5 sponsors: Atkins, Fateful and Gould, IES, NPS Group and Wilmot Dixon for their support in helping Spaces deliver this virtual conference. All the webinars over the 2-week period are being recorded and will be loaded into the Spaces YouTube channel. Delegates and Spaces members will be sent a link at the end of the conference. The recordings will only be available to these delegates and Spaces members. If you have any questions during the webinar, please include them in the chat bar and we'll try and answer them moving forward, either in the webinar or at the end. So into this morning's intro into this morning's webinar. This is an introduction to Feilden, Clegg, Bradley Studio, FCBStudios, Carbon for Schools, Understanding Carbon from the Outset, presented by Dr. Joe Jack Williams, Associate Researcher with Feilden, Clegg, Bradley Studio. Joe, alongside Ian Taylor, leads environmental research at the practice, identifying and developing and enabling research across sectors and projects. His specialism is the influence of the school building on the students, measuring perceptions, environmental performance and building form, as well as predicting, measuring and mitigating carbon impact of architecture. He has taught a number of universities in the UK and is part of a core research group with Architects Declare, CIBSE and LETI. This talk will introduce FCBStudios Carbon tool as a free way of estimating the whole life carbon of a school from the very beginning of the design process, ensuring the operational and embedded carbon remain part of the design decisions. Dr. Joe Jack Williams, welcome and thank you for supporting the Spaces 2021 conference.
Brilliant, thank you for the introduction, Steve. Much appreciated. Yeah, so as Steve mentioned, I work for FCBS. We are a large architectural practice, and one thing we've always been pioneering on is sustainability, and I think this is kind of a nice sort of evolution. So it's really great. You know, we've been doing this for 40 years, so it's really fantastic to see the Spaces as an entire event dedicated to net zero carbon. I think incredibly topical, and it's fantastic that we're able to support it in some way. So I'm going to talk to you about FCBS Carbon today. This is our carbon tool. It's free, and I'll show you some links about how to get it later on. And it comes out of the back of, you know, some nice puff piece. We've won lots of awards. We're very good. I would say that. This really comes out of the back of Architects Declare. Back in early 2019, those are the days where we see people again in person. We helped set up, and we were a founding signatory of Architects Declare, so Peter Clegg and others sat around, Steve Tompkins and Michael Paulin and lots of amazing sort of leaders in architecture, set these 11 commitments to mitigate climate change and the biodiversity crisis. At the time, there were 17 of us. Now I think there's 1,000 plus. I think it's across 25 plus countries. It's not just architecture, it's all the construction. So it's building services, it's landscape, it's structures, it's civil engineering. It's amazing. It's really taken off. And one of those key commitments in there is a commitment to share knowledge. So fantastic events like Spaces have been doing this for years, and really what we wanted within Architects Declare is an explicit realization that if we don't share knowledge, we'll never overcome climate change, and it makes it far more inevitable. And FCBS Carbon really comes out the back of that principle of commitment to share knowledge. It's really important that we all start to, you know, not about being non-competitive, it's about ensuring that everybody has that kind of baseline of knowledge to make sure that they can make the informed decision that's correct for our climate. So I'm going to quickly talk about our route to zero carbon as a practice, a bit about the role of FCBS Carbon, understanding how it kind of sits and, you know, what it actually is, and I'll give you a demo of FCBS Carbon, and we'll have some Q&A at the end. If there are questions, I think Steve just mentioned in the chat bar, I'll sling them in. If I can spot them in time, I'll try and wiggle it in. If not, we can pick it up towards the end, but don't be shy. So this is FCBStudios route to zero carbon. By 2025, we want all projects starting on site to be able to achieve net zero carbon in use, which is terrifying. It really is. I mean, it's a huge ask, and we're still trying to work out exactly how we do it. But the idea is that gives us a few years to build the building and a few years to kind of settle and let things settle down for 2030. The idea being that we'd be net zero carbon by 2030. Huge, huge commitment. And really, when you look at FCBStudios as a practice, this is number of projects per RIBA stage. You can start to see that there's quite a few projects that we've got kicking around, and how do you kind of deal with that? And really, the kind of realization that these projects are probably at stage 5. Nobody's going to thank me if I turn up and tell them they've got the structural systems wrong, there's a better system they can use, or you should be using CLT. Really, we want to be making those decisions at the very outset of the project, so we can understand that everybody's on the same piece of paper, everybody's saying, okay, yeah, great, we're all working to the same target, we've all got the right sort of ideas, but if you start on the right foot, it's much easier to keep that going. If you get to stage 3 and say, well, actually, well, maybe we need to have a rethink, it's a huge cost implication. I've said it's progressively more difficult. Actually, by difficult, I mean more expensive. That's the kind of long and short of it. We can make all these changes. We're all capable of doing it, but it just costs cash, and that's not really very efficient. So really, I'm looking at kind of stage 0, 1, 2. This is where we need to be making those big decisions about carbon, and where we can really have influence, where it doesn't cost particularly much to the client. It doesn't cost much to the design team. It's much easier to build it in at that point. And it's really difficult because at these early stages, we don't know much about the project. At stage 0, it might just be a kind of recognizing we need a building. So how do you kind of deal with that? And if you think at, probably at stage 2, we start to have a building, you can imagine very quickly, if we had a design, we might have 2 versions of massing. We never have just 2 versions of massing in the practice. We've always got many, many more, I'm sure. And each one has a different set of structure. Each one will have a different kind of facade materials, different floor types, different glazing approaches. You can imagine that, if we just had 2, that's easily 108 design iterations. And that's a kind of simplified version. To understand in each of those the carbon implications, it's a huge ask from anybody. So how do you know you're always making those kind of right decisions? And really, to understand whole life carbon, operational carbon is one thing. I think as an industry, we're pretty good at it nowadays. I think there's still gaps. We still need to keep pushing at it, but we're not too bad at it. We've got a grasp of the kind of key ideas behind it. But really, for whole life carbon and embodied carbon in particular, we need a bill of materials. So you can imagine if in that kind of previous scenario, I need a bill of materials for 108 designs, which nobody's ever going to make because it's almost abortive work for 106 of them, say. So really, what we did instead was take a slightly different approach and a slightly different tack. We just want to know the impact between the 2 decisions. So is it better or worse? So we created a library of standard construction build-ups based on what we use as a practice. Just a kind of rough idea of, this is what a facade looks like. This is what a floor could be. And then we use an algorithm to describe a building based on some key parameters. So the idea is it's kind of, it's not a real building, but it's a kind of standard building. And really, it's about recording the details of our project. So for us, we've got this route to 2025 for zero carbon in use. So how do we record that? How do we make sure we're progressing towards it? We also need to be able to estimate it in that first instance to make that record. And then thirdly, it's about understanding it. So embodied carbon and whole life carbon is a slightly different viewpoint. It's certainly really picked up in the last couple of years. It's obviously been around for many, but last couple of years it's really come to the fore. I think a lot of people are still struggling to understand what it is and how it works and what the kind of key drivers are. But so this tool is really there to help people play and understand and tinker with it. It shouldn't be daunting. It allows people to explore it in their own way. I think it's much easier for people to see it with a building rather than kind of just read about it. It makes many people learn better that way. It's really made at those early design stages. It's a bit like the notional building and SAP, if any of you are familiar with that. it's not a real building as such. It's kind of indicative of a building, but it gives you a kind of consistency. So what it means is that the direction and the magnitude of change when you change something like a facade material, although the outcome might not be perfectly accurate, and FCBS carbon isn't hugely accurate, it's kind of fine, give you the right kind of ballpark for most buildings. It will be consistent. So if you change a material, it will tell you whether it's going up or going down. And that is really helpful to understand the scale of up and scale of down. Is it gone up by 1 or has it gone up by 200? You can see that. The other kind of key thing with this is it's based in Excel. So there's really very few borders to adoption. Lots of these tools that require expensive CAD packages or similar. This is done in Excel. Nearly everybody has access to Excel. We haven't checked whether it works in Google Docs. I suspect it probably won't. I'm sure some of the graphics will go a bit funky. The numbers will be fine. But it means that anybody can use it. So it's not just about expensive consultants. It could be client bodies. It could be facilities managers. It could be, it could be architects. Who are generally afraid of Excel. So this is what it's actually modeling. So for those of you who are familiar with the LCA modules, the life cycle assessment modules, these are from BSEN 15978. This is how I represent them. There's also other ways of drawing them as well. And basically what it's saying is that we take it all the way from the materials we make being from a hole in the ground, all the way from transport, manufacturing, transport to site, construction, the kind of wastage, use, repair, maintenance, how often things have been replaced as well. We do operational energy use, and we also do end of life. So what's going to happen at the end of the life? Is it demolished? Is it burned? Is it transported to a processing plant in Turkey, as it turns out quite often? And then does it end up in a hole in the ground, or where else does it go? We also do some Module D. So Module D is about reuse outside of the boundaries. So it's a really kind of complex area, Module D, so I probably won't touch on it, but we can talk about that if people have specific questions. We don't do water use. I think it's kind of difficult to predict. Weirdly, I don't think loading units are quite the right approach. We are looking at it, and it's incredibly important. I would say that water is not hugely important in terms of carbon. It's more about water as a precious resource, certainly to me anyway. So what we do in that kind of first stage, so A1 to A3, we get those bits of data from environmental product declarations, or EPDs, or the ICE database, which is the inventory of carbon and energy, which is from Circular Ecology, and it's free. Really good. If you haven't seen it, do have a look at it. Gives you kind of standard tables of figures. And then these are estimated as percentage uplifts on A1 and A3. So all those kind of A4, A5. It's very difficult to predict. It's very much about how you build it and how you maintain it and how those things are going to be assembled. So we kind of use average percentages. It kind of gives you a good start point. I would say that predictions could go up as well as down. It sounds like a financial warning, but it really can. Figures from the ICE databases are averages. Figures in the rest of it are also averages. You can pick better materials and you can pick worse materials. Just be aware of that. So on to actually how it works. So there are 3 input pages and 2 output pages within FCBS Carbon. The inputs are in yellow, boxes in dark blue and grey are kind of calculated. They should be fairly colourblind friendly. That's the idea of them. The idea is that you just work through from 0 to 4 and you'll see the whole picture of the project. I would say we've done it as linear kind of thing because that's Excel. It likes a linear format. It really isn't linear. It's about playing and tinkering with it. So don't just work your way through it and go done. Work your way through it and then go back and play with it and change stuff and really get a feel for it. So on the first page, this is the input page. It's kind of the boring bit, if you like. It's the kind of setup for the rest of the project. What I would say is it's full of global variables that if you don't fill in, things will break and you won't necessarily understand why. The classic one is estimated year of completion. Make sure it's either this year or a year in the future. Don't do a previous year. We actually estimate, predict decarbonized grid and things like this. So it does pull in kind of a few other things in there. So just make sure it's this year or in the future. Sectors, there's only 2 sectors in the available one that's online. So there's housing and offices. So this is ostensibly about schools. Treat them as domestic and non-domestic. That's probably what it is, more than housing or offices. Actually, it doesn't really make much difference for the embodied carbon bit. The only thing that makes a bit of a slight change for is the operational energy predictions. I'll show you those in a second, so you'll be able to see those. The space for text, if you want to write down some environmental objectives, I recommend you write them when you think of them, whenever you get the chance. At some point, I'm sure all of our buildings will be going for awards or something similar. It's nice to have those written down somewhere so you can find them again in the future. This is the input and the operational energy page. Quite a lot going on. You have these kind of graphs here, so we're always comparing things to the RIBA 2030 challenge. It's, for an architecture practice, it's important for us. On the left down here, and I realise you won't be able to read these, and when we show you the spreadsheet, I'll show you in a bit more detail. We have a little bit which gives you benchmarks for electric and non-electric energy use, effectively electric and heating, if you like, heating for water, and breakdowns according to, which will align with things like TM22 or TM54 as well, about how you're going to use your energy. If you know those figures, brilliant, amazing, you're ahead of the game. I'd say most people don't, and most people actually just kind of estimate it. And down here, we've got some power generation at the kind of bottom left, so maybe it's PV panels or solar thermal. Just to note on these graphs, you will see there's two lines in the graphs. One is gross demand, the other one is net demand, if you like. Now, we're always reporting both. We want to make sure that we're low energy first and then using renewables. That's why we report them separately. This is the kind of the main bit of it. This is the embodied carbon page. Again, just the bits in yellow we're going to have to fill in, and it looked fairly daunting, but most of it's done for us. So in here, we've got a kind of standard parameters. So these are things that are specific to our design and tend to be things that we can measure off. You know, maybe it's a SketchUp model, maybe it's a hand sketch. I've done previous examples of this where I've done talks where I've used Google Earth for an existing building. So we've measured off Google Earth. Actually, it works kind of fine. But kind of standard bits and pieces. It's not too tricky to be able to do. And the key here is put in your best estimate. If you're not sure it is, we can always change it later. And you also see how sensitive things are. So you can put in a glazing ratio. Maybe you want to use the LETI targets. Put that in there. Maybe you want to just see if that makes a big difference. But if it doubles, you can just change the number really quickly. Build up the rest of your building, change it, see what happens. It might not make very much difference. It might make quite a lot of difference. Difficult to know. So put in your best guess there. In here, so this is where you start to select materials and talk about the materiality of the things that are going into your building. The first three columns are all about materials and constructions. So the first one is building aspects. This is according to the RIC standard, so it's substructure, superstructure, things like this. And then the second one is the actual building elements. So maybe that's piles or pile caps, or it's cores, it's columns, it's facades, it's flooring, whatever else. There's kind of subsectors. And the third one is materials. These are kind of curated build-ups for it, and it could be something as simple as it's just a solid lump of concrete, or it could be quite a complex steel framing system with a ceramic tile facade or something like that. We build all that up for you. You can say whether it's new or if it's existing. So if you're working on an existing building, you can say it's an existing building and add those bits in, or it could be it's reclaimed materials, and you can say they're existing again there, and that kind of helps. There you can put in component life as well, really important. We need to look at those replacement cycles. It can be huge, so do be careful when you put those in. There's another column in here called the adjustment factor. I'll show you how that works. What the adjustment factor is basically there is to say that the way the building is modelled within FCBS Carbon, it's kind of an adjustment factor to help you make sure it's a bit more responsive. So it could be as simple as you might want to put in 2 lines, so you can add in more lines. You might have 2 or 3 different floor types. You might have wood floors, tiled floors, carpeted. So you could just split them out, by percentage, or you might have an area where you've got, say, a particularly thick slab for some reason. Your floor slabs might be really thick because it's got high loading. What you can do is on the right, there's an assumptions column, and you can see in that assumptions column, it'll tell you what the build-up is assumed to be, and it will tell you in there how thick we assume the slab is. You can put an adjustment factor in there, say 200. You want to double it, 50 if you want to make it thinner, all those kind of things. So it's a fudge factor really. And this is kind of what it's modeling behind the scenes. You can't necessarily see this, but really we use stuff that we build in FCBS Carbon, and we take those and start to assume talk about what's going on with it and build all these bits up. So we've got steel framing systems, we've got all the kind of materials that sit with it. So we put those in. You don't have to think about it. You just want to have to think about the kind of end result. And just for those who are kind of tinkering and want to know how things fit with each other, when you change things on the left, so that on the left these are things that are kind of variables that we can alter. I would say grid size we can't alter it yet, and building load and partitions, these are set by sector. So you can change the sector, not change those. You can't as yet really edit them as yet as a user. The other bits here are ones that we put in those kind of little drop-down bits that input to. And these bits will show you where the impact. So these are your kind of building elements, and it will tell you very quickly. If your building's emitting an awful lot of, say, structure, substructure, you can see the things that will affect the substructure. So you can tinker and have a little iterative play with it. So onto the outputs. So these are presented in a way that hopefully means you can just print them off and stick them in a report, and everybody's got all the information they could ever want. There are tons and tons of ways of cutting and slicing all this information, and everybody wants it slightly differently. This is our current best thought, but if you've got particular needs or asks, let us know. We can maybe start to build those in for you. On the top left, we have, oops, if I click back on here. So on the top left, we've got operational energy. Bit of a summary of the graphs you saw on the input page. So at the top, you've got our RIBA 2030 challenge bar. And then you've got the 3 bars showing about electric, non-electric, and total energy demand. We've got a few bits in here about energy uses, renewable bits, annual carbon emissions. So we've got carbon emissions based on current Part L and SAP 10.1. So you can get an idea, just a kind of rough feel about how it sort of sits. In the top right, we've got embodied carbon. So this is showing full embodied carbon. So it's not just the kind of upfront, it's all the way to the end of its life for a 60-year period. Again, we've got the RIBA 2030 challenge at the top. Again, 2 lines, net and gross. So we've got one which includes sequestered carbon, another one that doesn't. So you can kind of see those, nice there. We don't include sequestered carbon by standard. So it's always going to be a kind of addition. You should always report it as a separate line item. Bottom left, we've got whole life carbon. So if you want to see how it goes in a bit more of a standard way, so 30, 60, 90, 120 years. That kind of blue bit being your embodied carbon. Operational carbon, sorry, in the dark black, darker blue bit being the embodied, and then the below the line is I think that's renewables or sequestered. So we can kind of see those other bits that are seen with it. So you can start to see how it works. Again, we'll show you this. So it tinkers. You can see replacement cycles and the impact of that as well. And then at the bottom we've got our offset carbon. So some people struggle with what carbon is and trying to understand what's good or bad about it. So we turn it into hectares of forest because everybody loves a forest and it's a bit easier to see, really. We've got some indicative costs for different systems. We don't necessarily endorse them, but there's one which is about planting trees, which is from the Woodland Trust. The other one is about in-state improvements. So it's kind of improving somewhere else to offset your carbon. So we've got the Camden Warm and Well Fund, which I think still exists, but it's part of their kind of offering for zero carbon in their borough. For those of you who are really into embodied carbon, I'm sure by now all of you are. It's kind of an interesting. This page is probably the more interesting one. If you want to report some of the figures, what we actually have here is in the top left a kind of breakdown per stages, so you can kind of see where it's all being emitted. So in this project here, we've got quite a lot of biogenic carbon in the first column. See, it's below the line. Next one is our A1 to A5, so that's our kind of upfront carbon. So all the carbon that's emitted before somebody moved into the building, really quite high. The other one I'm really interested to note here is this sort of blue column here, B6 and B7. So operational energy, so you can see operational energy over 60 years and the initial upfront carbon of building the building, about even. So quite an interesting take. So you can start to tinker with that. And up here we've got a little breakdown, so you just want to see the figures and the numbers. You can take that straight out of there, nice and easy. And then the bottom left, for me, this is the one I use most often. I find this one a bit more engaging. We're looking at a kind of line chart just showing exactly how the building's going to be emitting carbon over 120 years. And it starts with that kind of upfront carbon. So and then each of those little lumps are replacement cycles of bits of equipment. We use 2 lines. There's not a lot of consistency about how we do include some things and not other things. So the red line being the kind of worst case scenario. So we use just current grid factors. We don't include PVs and the kind of any energy they generate, and we don't include any sequestered carbon. The green line is the kind of optimistic version, if you like. So it's got sequestered carbon. It's got grid decarbonising figures. So you can see there should be a slight little curve to it. And we include renewables, so you can kind of see the difference between the 2 of them. So really kind of useful. And again, you'll see these in a bit more clarity when I actually use the spreadsheet. So probably the project will be somewhere between the 2. But it's useful to see it. It's quite nice to see these, particularly these little jumps and bumps where you replace things every 20 years. This has probably got services every 20 years, and here's probably something structural, I guess, at kind of 80 years. So on that note, I'll give you a quick demo of it. I'm going to show you how it all works. Thanks. Let's turn my screen share on. So just for those that are interested, this is where you download it from, so FCBStudios.com/FCBS CARBON. It's free, you just need to put your details down at the bottom. I obviously don't have this open all the time. This is just for yourselves. This isn't my background or anything odd like that. There's a video here. It'd be very similar to this one, although I'll be Joe Taylor also did some of the talk, and he's probably a bit more eloquent than I am in some ways. So here's my building. It's an absolute beaut, as you can imagine. For clarity, I'm an engineer, not an architect. As you can see, we've got a basement floor. It's a bit difficult to see, but actually we've got a slightly taller ground floor compared to the other floors. And it's slightly, it's not quite square. Oh, it's lovely. So the question is, how do you model that building in it? So you've got kind of all these dimensions. If I open one of these up, so if I go here, so when you open up a spreadsheet, it will look something like this. This just gives you a bit of background info. It just basically says, don't sue us, and thanking all the people who helped us develop it. So many people did input into it. In here, this is where you'd import the data into it. So if I just zoom in a bit so you can actually read it. We've got an example office. So we've got FCBS CARBON example name, estimated year of completion. Again, so this is in the future. We've put in office, so in here we've only got 2 options, housing or office. And in here we've got subsectors. If you were to use this for housing, there's quite a few different versions. There's single family house, multi-family house, all these kind of bits and pieces, but we're going to go back. We're going to stick with the office to make things nice and easy. GIA in meters squared, dates, things like this, and here's a nice little box you can put stuff in if you want to put it. There is space to put a project image in. We haven't quite worked out the best way of doing that, so we've just kind of parked it for the minute. So when you open up input 1 into operational energy, so you should be able to see this now. It tells you a bit about it. This is what our project's called. In here are benchmarks, sector benchmarks. If you work in offices or housing, this is going to be really useful. I'll tell you all about it. If you're working in schools, it's not going to be so useful. In those kind of situations, this was about schools, what I do is I go to the CIBSE benchmarking website, have a little look at it, pick out the figures. It might be that you want to hit the LETI targets of 65 kilowatt hours per meter squared per year. That's kind of fine. We're going to take a bit of an estimate because it's a very early days. We don't know what the building's going to be doing really. We know it's just going to be a kind of school. Now I work in schools, and I think probably 110 is kind of fine. Not super go-y, but pretty ambitious. Okay, it's not going to be. We have to have a bit of thought on it. I'm not going to have any gas on there. It's all going to be electric, so it's not going to be heat pumps because I want to leverage that decarbonising grid. And you can see that we've got some kind of benchmarks we're set against. You can see how we sit against the ROVA 2030 challenge there. We are going to put some PVs on the roof. Now, if you wanted to estimate PV power for your roof, you get something like PV watts. Great, free website. Do have a look at it. Just note this is per meter squared of the GIA. So work out what your total PV array will provide, and then scale it down to your GIA. And you can see we've got these kind of 2 lines there showing us net and gross, if you like. So there you go, kind of straightforward to put it in. If you've got more figures, brilliant. This is the bit that's probably the least clever of the tool. It requires a bit more manual input. It's the bit we're working on most of the minute. So this is the embodied carbon page. So when you open it up, it'll look something like this probably. It'll look probably a bit more zoomed down. But if we zoom in, and you can see I've already pre-populated this because nobody likes watching people fill in spreadsheets on a webinar. In here, you can kind of put these bits in. You can see I've selected these bits. Just a note on here, if I open up the SketchUp file again, our building was a bit wonky. So we've got 25 meters on one side, 50 meters the other side. The way I input that into here is I've put that in as 20 meters as a building width. So the building width is the narrower of the two dimensions to it. And really, if you've got a building with a courtyard, say, it might be better just to kind of assume it's a long, thin building. It doesn't matter about orientation. Currently, we don't really use it. So you can kind of unwrap it, if you like, and the width would be the thickness between the outside wall and the inside wall of that courtyard. All it's used for is setting up it's just a kind of structural grid system. So what we could do is we could assume it's square and we get a rough idea, but actually we want to know how rectilinear it is. So that's what it's there for. A quick note of floor to floor height. The easiest way to do the floor to floor height is if you take the total height of the building above ground, divided by the number of stories above ground. That's the easiest way to do it. If you've got 20 different sizes, it doesn't really make much odds. If you've got an atrium in it that's, you know, fills up space, or a sports centre that's, you know, fills up half the floor plate, you know, don't worry about it. Take the full height of the building and the number of stories below it, and it'll sort all those bits out. Stories below, above and below ground, so nice and easy. So we're going to start here, and I'll start building these things up. Now there's a kind of key note here. So these are our pre-curated materials. So we've got piles in here, so I'm going to go for kind of this. We're not going to have any GGBS. Put those things in. Just note it comes in an estimated quantity 0. Piles is the one which is slightly weirder compared to the rest of them. The piles are dictated by the weight of the building. So when we build up the rest of the building, the pile figures will change. So just be aware of that when you first put it in, it'll come at 0. So you'll start to see those update as soon as I put the bits in there. I'm going to put some pile caps in, some capping beams. We've got piles, we've got capping beams. We don't need a raft foundation, so we can leave that one blank. We do have a basement, so we've got one floor of basement, so I'm going to put that in. Lowest floor slab. This is often overlooked. It's the bit on the ground floor. It's not one of the floors. We've got a core in here. So we could fill all these bits in, but that's kind of fine, isn't it? I won't go through all those bits. But you start to see as I add things in, if we put in columns, and we put in some columns here, you'll start to see the pile figures start to increase. I won't fill it all in now because it's unbelievably tedious watching somebody fill these things in. So I've gone through and already pre-filled this in the Blue Peter fashion. I've gone through, I've identified all the bits we've got. So we've got a kind of concrete frame structure, concrete floor slabs. We don't have any secondary beams or any beams at all. They're actually just columns with slabs running all the way across it. They're doing all the work. Maybe we want to put some beams in. We can have some beams in if we want. Why not? It's kind of fine. We've got some insulation in here, roof finishes. What I would say is our floor slab, when I look down here, our floor slab is 150 mil, is how I've set it. That's like kind of standard. Actually, we think maybe this is going to be slightly bigger. So if we get rid of the beams, go back to our floor slab being twice as thick, it's doing all our structural work. Long spans, so we put in as 200%, so that means it's now going to be a 300 mil thick slab assumed. Similarly, in here, we're going to have raised access floors throughout. 70% of it is going to be carpeted, 30% of it is going to be vinyl, so you can build these things up as you can imagine. I know in here, we've input in here component lives all the way through. Nice and straightforward. We could say things are going to be designed for assembly if we want them to be designed for assembly so they can be reused, and that'll help on module D figures. But otherwise, that's kind of it. It doesn't generally take that long. So now we've got that built up, and it does give you kind of indicative figures at the top here, so you can kind of see where we're sitting. So a bit of a spoiler, our kind of standard concrete frame building isn't doing hugely well. It's about 890-ish, probably a bit difficult, but it'll be a bit easier to read on here. So this is output 3. Just that kind of summary page as discussed earlier. the things we're kind of interested in is carbon factors down here, you can see, and these carbon bits here. So if I zoom in on this, it's a bit easier to read. So we can start to think about, okay, so we're at 889. There's a small amount of sequestration. I think it's probably bits of timber, certainly the raised access floors, we've got timber cores in there. It looks like we've got some timber in the windows as well, window frames. Services, absolutely huge. Finishes, substructure, upper floors, you know, there's an awful lot seems to be sat in those kind of bits. So maybe that's something we need to have a little look at, and we can try and fix those bits. When we look at it over its life, you can see that embodied is pretty big, but it tends to be about 50-50 all the way compared to operational carbon. And if you want to see how many hectares of forest, there's be 22 hectares of forest to offset our building for 60 years of whole life carbon. And if you start to look at these bits again, you can see that operation is pretty high, and you can start to see the difference in grid factors and what they make over different times. So with renewables as well, also kind of helped. And again, these little replacement cycles of services and a bit of structure there. So if I go back to here, I can see that my services have been replaced every 20 years, and also bits of structure in 100 years. So we can go back and start to tinker and change these bits. So I'm going to go back to, this is another version of it, again, so you don't have to see me endlessly enter bits of boring data in. One thing I've done is I've got rid of the basement. I think maybe let's try and avoid the basement. So I've gone 7 stories above ground rather than 6 stories above ground, so I've pushed it all up a bit. I've reduced the floor-to-floor height. I've just taken it down a little bit, so now it's 3.95. It's a little bit easier to do. Glazing ratio is out the same. What I've done is I've added a bit of a concrete mix. So in here, you can see there's all of now where it's concrete before. I've just added in 25% GGBS mix. So that kind of, hopefully that's going to help a little bit, and we can start to see whether that's made much difference. So if I go into the output now, let's just check out maybe the changes to it. Well, that's kind of fine. And you can see if in here, we're down to 802 kilograms of CO2, so it might be a bit difficult to read on your screen. There you go. So we saved about 85 kilograms of CO2. Bloody brilliant, really good. Not bad. You know, it doesn't take very long to make those kind of savings. We haven't really changed much. We just kind of changed that. Taking that basement out, bump the building up, use some GGBS. Actually, 25%, not an outrageous amount. It won't affect the program too much. Well, we can probably do a bit more than that. We can probably really start to tinker with it. So we can go into, this is my third one. Again, all I've done in here is we've gone for a super green version, if you like. So I've improved the GGBS content, so I've gone to 70%. Obviously, we're going to have a lot of program implications as a consequence. I've kept all these the kind of same. Just a note, if you are changing these global parameters, be really careful that you're not changing something that would affect your GIA. So with GIA is input manually by you on page 0. If you do change things like this, it will have kind of odd effects. Just make sure you change them both at the same time. So I've gone for a kind of hybrid structure in this one. So I've got steel columns and beams with some secondary beams in there as well. We've got CLT floor slabs and CLT roof. Otherwise, very similar. I've got CLT partitions. Maybe you want to have something else. Something else I could probably put in there. So raised access floors tend to be huge, can be a really huge kind of bit in here. But they don't necessarily have to be brand new. If you think they have to be, tend to be wood core with a kind of galvanized steel wrapped around the outside of it. We could reuse them from old buildings. Really easy to do. They just take a bit of cleaning. They don't tend to look so nice, but that's kind of fine. So we can change that to existing. What that effectively means is that we've taken, although we account for it, we don't include it in the final calculation. So we've got a figure for it. It's just not included. If you wanted to in here, you could put age of if existing. So some things will only last 60 years. And if you take something out of a building that's already 30 years old, and you say in here it's only going to last 60 years, it will assume that that 60 years starts from the original 60 years ago, so 30 years back. Just be really careful when you use that. It's a bit of a tricky thing. It's there for completeness. We don't really expect anybody to use it unless you're really getting stuck into kind of refurb. If you are, that's really exciting, but do be careful with it. Services, we changed the services down to low. This estimating embodied carbon surfaces is really difficult to do currently. CIBSE TM65 came out in January this year, which is great. I think prior to that, there wasn't really much there to help guide sort of what the kind of figures would be. These are taken from a Scandinavian study, actually, which is a bit of an estimate. So what we've got is low, medium, and high. Low is effectively saying it's sort of 40 kilograms of CO2 per meter squared as a kind of flat rate, and it's openable windows, and it's kind of perimeter radiators and a gas boiler. Kind of simple stuff that we've got in most buildings, most existing buildings. Medium, we're kind of heading up into positions where you might have a bit more to it. So you might have a bit more extract fans. You've probably got some, maybe it's an air source heat pump, perhaps, doing the main kind of lump of it. But probably, maybe it's mixed mode, but not a kind of fully conditioned space. And high is your kind of classic high-end city-based trading floor, if you like. Full air conditioning, full mech vent, sealed box, loads of equipment gone into it. You can kind of imagine the kind of place. So that's kind of how we see it. What I would say is services tend to be pretty large lump of embodied carbon, so really pay attention to component life. So in the previous ones, I had the component life down to 20 years. In here, I've changed it to 30. Recognizing that schools perhaps maybe don't get as much love as they should. How can I delicately put that? I think that's probably delicately enough. If it had more funding, I'm sure it would be far more often and probably a bit more proactive rather than reactive. So in here, you've got this. This is where we're at. So if we look at our kind of output page again, I zoom in on here, so I can get it down to 600, which gets us pretty close. We're still in the green. We're not quite in the kind of sweet spot of the green bit here. So we can kind of start to tinker with these bits and pieces and play with it, understand how these things go. So maybe it is about saying, well, maybe if I reclaim these bits of steel for another building, how does that go? Does that work? To make a big difference? Oops, click on the right page. There you go. So I can get it down there. So we'll just need to find an existing building with perfect steel so we can just kind of wiggle in. But I think that's kind of it for me in terms of demoing the tool. It's always very difficult to kind of whistle through these. There's so much you can do with it. But again, maybe there's questions you want to ask, and I can pick it up, or maybe there's bits you want me to test out in it live, and we can see just how quickly we can break it as well. Kind of good fun. But thank you very much. So I see there's some questions coming through. Yeah, good.
Okay, yes, a few questions there. Perhaps if we, Joe Jack, if we go from the bottom, sort of when they're coming through. First one was from Greg Keeling. How has this worked with your clients? Have they made early changes as a result of seeing the implications in a very clear format?
Yeah, so this does work quite well with clients, actually. We've been trying this in a few of our projects. And what's really nice is we can start to talk to them about the impact of form factor, but also the impact of materiality. If you think that we love people building timber, but it comes with inherent risks, actually being able to quickly quantify the carbon impact gives them an understanding of why they would take that risk on. So it's about having a properly addressed risk conversation rather than just saying timber's nice, isn't it? We can be really finite and say, well, actually, you'll save X percentage. And just note, we do tend to report it in terms of percentage savings rather than ultimate figures. We make these changes just because at those kind of early stages, things can change very quickly. There's lots of variables in it. So what we really want to try and do is avoid setting a kind of target for ourselves. We do talk about percentage improvements. But yeah, it does work really well. And the thing is, we can build up a building in a meeting in an hour and iterate through it and find the lowest carbon response in an hour. Mm-hmm. So it's kind of good.
That's good, thank you. One for Giselle here. From your experience, what are the big wins that don't increase capital costs?
Yeah, great, good question. The holy grail, if you like. So the biggest wins far and away come within the structure itself, savings within the structure, actually an optimized structure. If you think sub and superstructure tend to be about 2/3 of the embodied carbon, it's the place to make all the savings. And it could be as simple as just changing the size of your grid. In fact, if you go to the iStruct website in their climate section, they have a fantastic free resources on things like lean design, materiality, producing structures that still meet health and safety requirements, the PS requirements. They have an amazing set of data on there that's well worth a read. The thing with those kind of savings within the structure, and we're not talking about changing materials particularly, we're talking about lean design specifically, they have significant cost savings attached to them. So if you can reduce the amount of material you use, there's a direct saving. If you can increase the buildability of it, there's increased savings. So one thing that's a really easy win, I mentioned about grid size. Smaller grid sizes means most of the way it goes into columns rather than the beams, but the columns work really well, far more efficient. It actually, it saves an awful lot of materials. It saves a lot on cost as a consequence, but also it makes it just that bit more buildable. So a bit of simplicity does kind of work. So that's where I'd focus on. And we are fortunate the iStruct have really pulled the finger out and done some amazing work. So it's well worth a look on there. Is
that perhaps something we can get a link to if we let Fiona know?
Yeah, I can link through a link to that. Yeah,
thank you.
There's some great work there.
Okay, just think, Giselle's got another sort of link onto that question, sort of supplementary one. That is, how do you manage product changes during construction? Contractors are usually keen to offer savings. I presume that's where the tool it can quite readily evaluate that.
Yeah, interestingly, it's a bit difficult. So we in the tool use generic materials, so they're averages. So by its very nature, we're never going to quite represent exactly what the contractors would use when they build it. When you start to get to contractors on board who are going to be building things, usually they're selecting materials and they're making design decisions. Actually, what we don't want to do is be really prescriptive and say your floor will emit X kilograms of CO2 per meter squared, because that's not really helpful for anybody, and it kind of undermines the whole tendering process. What we're interested in is the end goal. So the way we write our contracts and specifications now, or employers' requirements, depending on how it's going, we all set an overall target for it, and we all set targets and figures that say we expect X amount to come from the substructure, X amount to come from the superstructure. And then within that, the contractors, in much the way they do with cost or they do with operational energy, they can then make the informed decision about where they can make savings on carbon as well as cost, and where perhaps they can offset other bits which might go up. As long as the ultimate goal is there, I think that's the right answer. What we don't want to have is a really prescriptive system that means we don't get the benefit of the tendering system. So it is, and we recognise that we sit on one end of the kind of building side and contractors on the other side. That they're the ones that know how things are going to be made, what's out there, what's material. They're the one talking to suppliers and supply chains. They'll know what's easy to get hold of. So yeah, that's how we do it. So it's about ultimate targets rather than being into the sort of minutiae. Although we do provide that.
So it's using the tool as our original guidance, and then as the contractors get on board, it's getting using them to get a little bit more detail, verifying those figures. So you could, if there was a figure came in slightly different, you could sort of adjust the model to predict the impact of that. Okay.
Yeah, exactly. And just on that, I would say if you're still using FCBS Carbon kind of post stage 2, you probably would benefit from moving from this tool to another system or a bill of materials, or with the actual carbon factors, as you start to get more accurate quantity data. And you'll find that it's a bit easier to design against then, because it will represent your value just that bit more accurately.
So again, the tool is helping to get the right decisions early on, sort of, rather than it's the be all and end all. It's that making sure the concepts and everything are in place, and then working up the detail of that rather than changing it part way through. Good.
Yeah, exactly.
And just thinking with that, are there any guidance notes, or are they mostly sort of input into the document as you go through?
Yeah, so when you download it, it goes to the website and you download a zip file, so it has a guidance document.
Fantastic.
So it's all there, so you can have a look through it. Again, always happy for feedback. If people have got questions, send me an email. You just got to turn around over a couple of days, but it's not too bad.
Well, it seems like it is getting there. Try it, have a play with it and say and have that mindset that it's a case of, yes, there are things where you can put factors in to adapt to your particular building and things on that. Okay, right. Okay, just looking at a couple of other questions that have come through. One from Declan. How often is the tool used in feasibility studies? Has REBA, oh, he's just moved. Has REBA and other professional bodies considered promoting this tool at the project infancy to aim the client and end user to think about reducing their impact on the environment?
Yeah, we've actually been talking to RIBA client advisors about it, so that they are aware of it, and the RIBA don't necessarily explicitly promote any tools. As such, they do encourage people to use things like FCBS CARBON. There's HBERT as well, which is made by Hawkins Brown. So if you're into Revit, you can plug that in. That's another free tool, and that's great. In fact, it's not a bad way of doing it. If you're going into Revit, you can do FCBS CARBON before you get into BIM, and then you can go to HBERT once you get into BIM, and it can be completely free. Absolutely great way of doing it. Yeah, the RIBA have been very, very happy to kind of publish and promote. We did do a series of talks at the RIBA and included in there, and we do talk on lots of the bits. It is getting there, I think, is the kind of idea. In terms of how often used in feasibility studies, we've got about 2,200 downloads of the tool currently. And I do get a lot of questions coming through about how people are using it. It seems like most people are using it in feasibility studies. And it tends to be smaller practices. It tends to be mostly architects, lone practitioners, that kind of size. I hope they're all using it for feasibility studies. But, but yeah, so I definitely not a kind of definitive answer, but hopefully useful nonetheless.
Okay, and there was, again, another follow-on question, which you've mentioned there, is do you have any recommendations for tools to use at a later design stage? Can you just reiterate the what tools you were mentioning there?
Yeah, so there's a free one if you're in Revit land. You can plug in, there's a plugin called HBERT, which is free from Hawkins Brown. Been around for a few years. Great, nice and free, plugs into it and it gets kind of nice squizzy outputs. There's another one out there called EC3. I can send links to these kind of bits. And in fact, there is a talk that myself and somebody from Hawkins Brown did back in October 2020. Was it last year? Maybe it was last year. Time means nothing anymore. Where we did go through a series of these kind of tools, and you can kind of see exactly what it is. EC3 is a free one. It's American. It's all online. You have to put the values in manually. A bit of a pain, but actually it's got a much better database, and it's all free, and it's all linked to real data. If you want something a bit swizzier and a bit more easy to use, there's things like OneClick or eTool. Those are both paid for, both very thorough. Lots of good data within it. Usually a kind of similar sort of data set, but a bit more easier to use. They plug into things like, again, plug into Revit or SketchUp and these kind of things. There's one called PH Ribbon, which is good if you're into the world of Passive House. You can plug that in. That's a great little tool as well. I think that plugs into SketchUp too. So there's plenty out there. It's worth looking on. There's GLA guidance document which includes a number of tools in it. So
brilliant. Well, it's like all of those, they're probably being developed all the time, and as you say, it's just finding one that suits your requirements and how it works for you. Good.
Exactly.
Okay, just come back to a question from Philip Jordan. With the amount of new housing estates and therefore new schools planned, how might this relate to new schools? Or bite the rise of academies can mean the council's no longer the sole client body that they were post WW2 when system schools like Skoda were devised. So I suppose there's a couple of bits on there. It's just reiterating how the software tools can be used for it's office and domestic, but how it can be used, adapted to schools. And I suppose another one, I just sort of a question on those is how can that linked in with modern methods of constructions? How can we use the tool for that?
Yeah. So yeah, a couple of bits wrapped up in there. So use it on schools. Just use it as if it's an office. The only thing that will actually change is if you're it's the benchmarks for operational energy. That's the only thing that will be particularly different. So you can use it, just treat offices as non-domestic, which the RIBA 2030 challenges are for non-domestic. There is an update which will have schools in more explicitly because there's new LETI embodied carbon targets. So you have to explicitly meet those. So you can do it very quick if whichever body it is, whether it's the academy that's leading it or DFE or local council, they can model it up very quickly, and it could be a case of they've got a little idea of space and they could take it up from there. If you're at those early kind of stages, it might be kind of useful just to look at the LETI embodied carbon guidance. That'll give you some target figures to let you know roughly if you're in the right kind of area. But easy to do, certainly would work. There's no real difference to how I showed you working with an office. It'll all be kind of fine.
Okay, thank you.
In terms of systems and school existing buildings, yeah, I just noticed about the kind of systems. Yeah, most buildings are built around systems now. In terms of MMC, it's difficult to, if you're talking sort of volumetric, it probably won't work particularly well. It just won't represent the kind of subtleties that come with volumetric. If you're looking at something like componentized, actually it's probably not a million miles off. You could use it with the kind of standard build-ups. What I would say is you could probably go down the whole list of it. Any of those bits which are componentized, you can take off sort of 2.5% using the adjustment factors, put in 97.5, and that'll just be your kind of site wastage, which we add on at the end. So you'll just take that off.
Yep. So again, it's adapting the tool, but it's just getting used to knowing which areas you can change.
Exactly.
I suppose a similar question from Declan there is: can the tool be used in retrofit?
Yeah, exactly. Yeah, completely. In fact, so just a kind of note on its limitations. If you're doing small buildings, do check that the structural assumptions fit what you'd expect to see. Similarly, if you're doing tall buildings, again, you'll find very quickly things like column sizes perhaps aren't quite what they are, so you just need to be careful with that. The sweet spot for the tool is a 1960s or 1970s office building. That is the kind of limit of my structural engineering knowledge. But if you build up a building as I showed, so you just go through and select the materials, all the measured bits, select the bits you're going to keep, change them to existing, all the bits you're going to add in new, keep those in new. It won't do the demolition of the existing bits that you take away. They tend to be very minimal. It tends to be less than sort of 3 or 4% of the overall embodied carbon. So just bear that in mind. It's a bit of extra on top of it, a bit tricky, but it won't be hugely out.
Okay. Right. Just looking how we're doing for time now. I'll just see there's just one question I've just spotted in there from Richard Daniels. Does the tool include screw piles for residential? That's a fairly specific, but or is there a figure in there that can be adapted?
Yeah, so it does have steel screw piles in there. Again, the piles themselves, the size and the weight of the building. So you might find something odd, like it's like a one pile or something weird like that. But there is, yeah. So the steel, and when you're using screw piles, obviously the best bit about those is you can take them back out of the ground. Yeah. So just make sure you take that kind of design for disassembly, and you'll get those benefits in that module D section that we don't tend to include.
All right, brilliant. Thank you. Well, I'd like to thank everybody for attending the webinar, and I'd really like to take this opportunity to thank our presenter, Dr. Jo Jack Williams. This has been excellent. Thank you very much. It's a tool I've not seen before, so I was really interested in that one, so I can see how we can use that one. I'd also like to thank our sponsors, Atkins, Fateful and Gould, IES, NPS Group, and Wilmot Dixon for their support. There will be as all these other webinars, there's a poll coming up at the moment. If you could take a few moments just to answer that, please, where it's on a scale of 1 to poor and 5 to excellent. Could you rate the webinar for us, please, just so for feedback and for how we can use that in future events. As a reminder, that all the webinars over the 2-week period are being recorded and will be loaded to the Spaces YouTube channel. Delegates and Spaces members will be sent a link so they can view those. Thank you for attending today, and I hope this has given you a better insight and then some additional resources on how we can all help to move towards a zero carbon climate, that sort of economy, really. Thank you very much for your time today.
Great. Thank you all.
Okay.
Thanks.
Bye now.